Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 1, topic Non-Deterministic Finite Automata. Objectives are to understand the concepts of non-deterministic finite automata, to analyze the problems on non-deterministic finite automata. Non-deterministic finite automata. It is easy to construct a non-deterministic finite automata than deterministic finite automata for a given regular language. Here the finite automata are called non-deterministic finite automata when there exist many paths for specific input from the current state to the next state. Here every NFA is not DFA, but each non-deterministic finite automata can be translated into deterministic finite automata. Here also it is defined in the same way as deterministic finite automata, but with two exceptions. That means it contains multiple next state and it contains epsilon transition. In this diagram we can see one example. That means from state Q0 for input A, there are two next states Q1 and Q2. Likewise from Q0 for input B, the next states are Q0 and Q1. So it is not fixed or determined that with a particular input where to go next. So here the finite automata is called as a non-deterministic finite automata. Next we are going to see the formal definition of non-deterministic finite automata. It also has 5 states same as deterministic finite automata but with different transition function as shown. That means Q into sigma tends to 2 power Q. Here Q is a finite set of states, sigma is represented as the finite set of the input symbol, Q0 is the initial state, F is the final state and dou is the transition function. Here we have also some graphical represent. That means the state is represented by varices and the arc labeled with an input character show the transition. The initial state is marked with an arrow. Now we are going to see one example for non-deterministic finite automata. Q equal to Q0, Q1, Q2, sigma equal to 0, 1, Q0 equal to Q0, F equal to Q2. That means in the given question the states are represented as Q0, Q1, Q2. The input strings are 0, 1. The start state is represented as the Q0 and the final state is represented as the Q2. Using these conditions, we are going to draw first transition diagram. From the transition diagram only, you are going to draw the transition table. In the transition table, you have to mention the present state and then two columns you have to mention the input string. That means when the current state is Q0 on input 0, the next state will be Q0 or Q1. And on one input the next state will be Q1. When the current state is Q1 on input 0, the next state will be Q2. And on one input the next state will be Q0. When the current state is Q2 means on 0 in the next state is Q2. Likewise on input 1 the next state will be Q1 or Q2. Likewise from one state to another state your input will vary. For how the input is travel, your states also vary. In the transition table definitely you have to mark the start state and the final state. The start state is represented by the arrow mark. The final state is represented by the asterisk or circle. Thank you.